In this video, we're going to look at compound interest. So, what is compound interest? Compound interest is looking at how simple interest builds up over time. Now, you have to remember simple interest does not include the fact that once we gain interest, it adds up to your total, which then becomes your new principal amount. Which then means we should really be earning more money over time, and that means we should get more money because there's more interest added up. So if you're not entirely sure what I mean, we'll look at the next slide and then it should make sense to you. All right, so let's look at a calculation on how it works, and then I'll draw you a flowchart on the side so you can see why you would gain more money. If $10,000 is invested in a compound interest account at 4% per annum for 3 years, compounding annually, find the number of compound periods. So when it says compounded annually, what that actually means is that we have interest added on at the end of each year. So because this goes for 3 years and the interest is added on at the end of each year, our number of compounding periods is 3. So if we use simple interest to calculate our compound interest, then we need to do this 3 times. So let's look at how this works. We start off with $10,000. We're calculating first interest, by the way. Maybe I should change that. Whoa, what happened there? All right, so we want the end of the first year. We are trying to look at the amount of interest you earn. So the interest that you get is $10,000, and we get 4% per annum for the end of the first year, which means 1 year has gone past. So that means we get $400. Now, here's where it becomes really important. Because we have $400, we need to add that onto a total because this is at the end of the first year, we get extra money. So at the end of the first year, which will be our interest plus principal, you get $400, adding our principal amount, which is $10,000. We then, by the end of the first year, have $10,400. Now, that's great and all, we worked out at the end of the first year, but this goes for 3 years. So that means we need to look at the second year and also the third year. So let's look at the end of the second year. Now, the $10,400 is now our new principal because we started off the year with that amount, right? Because at the end of the first year, we didn't move any money, we didn't change any amount of money. That's what compound interest does. You leave the money in, so then at the end of each year, you have a certain amount of money, and then you can carry it over. So that means for our interest, we have $10,400 to begin with. Let's find the interest that you earn for that year. Doing the same thing, which then gives you 416. Then the total amount we earn would be our interest, which is 416, adding on with our principal amount, which was $10,400 for this part. We would then get $10,816. But hang on, this goes for 3 years, so then this new amount becomes what we start off with for the third year. So, because of that, we need to recalculate our interest again. We started off with 10,816. Let's find out how much interest we get, which is 432.64. Then looking at our total amount, we get 432.64 plus what we had at the start of the year, 10,816, which you then get 11,248.64. Let's have a look at how this changed over time so that we can see what happened in our calculation before. So this is a start. We have 10,000, okay? We then gain some interest, which we calculated to be $400. Then we're going to add this in total to get our new amount for the second year. So this is year 1, and this is year 2. Oh, sorry, this is start actually, which we then got $10,400. Now, as I was telling you, this amount of money stacks up over time. That means you'll get more and more. I want you to have a look this time at the amount of interest comparing the first year to the second year. We've got $416. That's $16 more than the year before, right? Which then means you are getting more and more money over time, and it accumulates over time. So for the next one, we then get $10,816. So that'll be year 2. Then, for the interest that we got for that year, for the end of year 2, we got $432.64. If we then add this up to year 4, sorry, I ran out of space, you then get 11,248.64. This is not year 4, year 3. Now, the reason why compound interest makes more sense for us to look at banks and stuff is this is normally what happens if you don't touch your money in your bank. You get a certain amount of interest, right? You save it up, then each time the interest is calculated, notice that you actually get more money on the different interest that you get calculated. That's the reason why you want to save money and try not to move your bank account as much as possible, because then this interest will stack up to become your new amount, which then means you get more interest because you're getting the interest based on your starting amount as well as the interest from the previous calculation. So that's the reason why compound interest actually makes more sense to look at in real life. Alright, so now let's go back to finding the total interest that we earned. By the end of it, we had 11,248.64. But then if you have a look at our starting amount, we had $10,000. That means we earned 1,248.64. That's quite a lot, right? We didn't have to move the money. The compound actually, sorry, not compound. By not moving the money, we got some money back, which is $1,248.64. Now, let's have a look just to compare with simple interest. So if whatever interest we got, we continually took it out at the end of each year, so we're left with 10,000. Then the total interest that we will only earn is 1,200. Notice that that is less than the compound interest. That's usually the reason why, if you have a compound interest account, you will more likely earn more money by putting it in one of those. Now, what is the difference if you have different payment times? So if you have a look at this one's compounded half yearly. So we need to look at every 6 months in this case. Because it's every 6 months, you'd have the first 6 months, second 6 months, third 6 months, and then the fourth, or at the end, I guess, at the end of 2 years. Maybe I'll change it to every first half of a year, second half of a year, third half of a year, and then the end of the cycle. Alright, now, why it's important to look at that? Well, firstly, see how that's per annum? When we use our simple interest formula to calculate for each of the halves, it's $5,000, but 5% per annum. But then because it's every half a year, this effectively gets halved. Because of that, you're going to get half a year's worth of money. So at the end of the first half of a year, you will get $125. Again, let's work out our total amount. It will be 5,000, adding on the 125, which then gives you 5,125. Second half of the year, or in other words, at the end of year 1. The interest that we would get will be 5,125 times 5 over 100 for half a year, which then gives us 128.13. And the total amount that you will get will be 5,125 plus 128.13, which then gives us 5,253.13. Alright, third half of the year. Third half of the year, we started off with 5,253.13. We get 5% per annum for it, but only get half of it because it's half a year for our interest. Which then means we get 5384. Sorry, wrong one. We get 131.33. And notice that the interest is increasing over time because of the starting amount that we get. Then the total amount we get would be 5253.13 plus 131.33, which means the total that we get would be 5384.46. Then at the end of the 2 years, the interest that we will get will be 5384.46, 5% per annum, half a year. That gives us 134.61, and the total amount we get will be 5384.46. Adding on the $134.61 that we got, and gives us 5519.07. Now, I want you to notice two things when we get to the end here. Number one, the interest that you get over time increases as we went. So by the end, you got $519 extra for not doing very much for 2 years. I should probably mention this interest rate is way higher than what you would normally get. But anyway, secondly, you might notice there is a lot of writing when we do it this way. So we're going to find a way where we can simplify some of this working out by simply finding the start and the end. This then brings us to the compound interest formula. So the compound interest formula lets you find the final amount that you have. So this total amount is actually the final amount at the end of all the compounding periods. If I can spell final, that would be great. Not writing great would be a good idea. Final amount. All right. That lets you find the final amount. All we need to know is the starting principal, but then there are different things involving the compound period for the interest rate and the number of compounding periods, which is N and R. Now, why it's important to know about the compounding periods. You saw in the previous one, every half a year, you only got half of the amount of the interest because it's not the end of a year, right? It's half a year, not 1 year. So it's important that you calculate these interest rates and number of compounding periods based on that. Now, I should probably also mention this is a way of counting iterations, what we've been previously doing, finding the amount of interest and also finding total at the end of different periods. They are called iterations, which we will talk about if you do general maths or further maths. And they show you calculations and what happens over time through different sequences. Anyway, so we're going to look at the compound interest formula and how we can calculate these things by knowing the compound period. So keep in mind that this lets you find the total amount. If you need to find the interest, so you need to subtract it from the principal amount. All right, so as I was mentioning before, you need to know about the number of compounding periods, and it's all based on the time when it gets compounded. So if it says annually, that's at the end of 1 year. So remember, compounding means that's when the interest is calculated. So if it says annually, then it's at the end of 1 year. If it says half yearly or 6 monthly, because there are 12 months in a year, it's every 6 months, then this must happen twice a year. Quarterly means every quarter of a year, so it must happen 4 times a year. Weekly, we normally count it as 52 weeks a year. That means 52 times a year. Fortnightly, that means 26 times a year. Now, it's quite important that when you do these calculations, you try and write these calculations down as fractions if need be, in terms of your interest rate, because you're going to be dividing it with these numbers. And try and be as precise as you can, because a lot of these decimals will change your answer quite drastically. So just keep that in mind. All right. So if our principal is $7,000, our interest rate is 5% per annum, and this is compounded annually, write down the total amount and the interest earned. I need to add a line where it says for 4 years. Okay, so this happens for 4 years and it's compounded annually. So because it's once every year for 4 years, that the number of compounding periods must be 4. Then our interest rate, because it's once a year, will stay as 5%, so that's 5 over 100. Because this is annually. If it says something different, then we need to change it. I'll show that to you on the next example. So total amount, 7,000, adding times 1 over the 1 plus the interest rate, which was 5%, to the power of n. Putting this in, we get 9116.30. Then we need to find our interest. Our interest will be the total, subtracting a starting amount, the principal, which then gives you $2,116.30. All right, now on this example, same amount of time, which is 4 years. However, see how that says 6 months? That means the number of compounding periods has doubled, because every 6 months for 8 years, or for 4 years, means it happens 8 times, because it doubles the amount of times it happens per year. So our interest rate is no longer per annum. Remember, per annum means per year, but this is not per year, right? This is every 6 months. Because it's every 6 months, you must only get half that interest, which is then 2.5%, so 2.5 over 100. So then when we're calculating the total amount, we would have $7,000 times 1 plus 2.5 over 100 to the power of n, which is 8. That then gives us 8,528.82. So then the interest that you get is 8,528.82 minus 7,000, which then gives you 1,528.82.